Your agent worked perfectly in the demo. Then you shipped it, and 3 weeks later your token bill quietly tripled while nobody touched the code. That's not a bug. That's memory doing exactly what you told it to do, and almost nobody reads the fine print. Here's the uncomfortable truth about agent memory. By default, most frameworks accumulate. Every user message, every tool call, every intermediate reasoning step gets stuffed back into the context window on the next turn so the agent remembers what happened. It feels like intelligence. It's actually a bill that compounds. A conversation that starts at 500 tokens can balloon past 40,000 by turn 30, and you're paying to resend that entire history on every single request. The agent isn't getting smarter. It's just getting more expensive to think. LangChain's answer to this is explicit and modular, which is both its strength and its trap. You choose your memory class. ConversationBufferMemory keeps everything, verbatim, forever. Great for a 5-turn demo. Catastrophic for a production chatbot. Conversation buffer window memory keeps only the last K messages, so it stays flat, but it forgets anything older than your window. And conversation summary memory calls the LLM to compress old turns into a running summary, which controls token growth but adds a hidden cost. You're now paying for extra model calls just to shrink your context. The point is, LangChain hands you the steering wheel and assumes you know which road you're on. CrewAI takes a different philosophy. Its memory is more opinionated and layered. Short-term memory for the current task, long-term memory persisted across runs, and entity memory that tracks specific people, places, or things the crew encounters. Under the hood, it leans heavily on vector storage and retrieval, so instead of dumping the whole history into context, it fetches only the semantically relevant chunks for the task at hand. That retrieval-first design means the raw context window doesn't grow linearly with conversation length the way a naive buffer does, but you've traded token growth for storage growth and retrieval latency. The bill moves, it doesn't vanish. And that's the core distinction people miss. LangChain's default failure mode is a fat context window. You pay per token, per turn, and it grows with the transcript. CrewAI's default failure mode is an ever-expanding vector store. You pay in embeddings, storage, and the compute to search it. One inflates your inference bill, the other inflates your infrastructure bill. Neither framework magically forgets what it doesn't need unless you configure it to. So what actually stops the bleed? Set hard limits and enforce them. In LangChain, use a windowed or summary buffer with an explicit token ceiling instead of the unbounded default. In CrewAI, put a retention policy on long-term memory and tune your retrieval to return the top 3 relevant results, not the top 20. In both, be ruthless about what you write to memory in the first place. You rarely need to persist every tool's raw output. Log it elsewhere. Store only the distilled conclusion. The mental model that saves you is simple. Memory is not free storage, it's recurring rent. Every token you keep, you pay for again on the next turn. Every vector you embed, you pay to store and search. Treat your agent's memory like a working desk, not a warehouse. Only what you need for the task in front of you, and archive the rest somewhere cheap. That framework choice you make on day 1 quietly decides whether your costs scale linearly or exponentially, so measure it before you scale it. Tomorrow I'm breaking down the exact retrieval tuning config that cut one production CrewAI agent's memory bill by 70%. Subscribe so that walkthrough lands in your feed the moment it drops.